Hi there, welcome to our HP live stream event here today. We titled this the 5 things you should know about HP printing. We're here in our additive lab just outside of Minneapolis in Brooklyn Park, Minnesota. My name is Charlie Seitzer. Been with Hawkridge for 3 years now as a sales manager here for the Midwest region for additive only. Over the last 12 months, obviously we've all had our fair share of webinars we've had to sit on. Today you will not see a single PowerPoint slide, so that's a good news for today. With COVID, we've really missed the chances to have customers in our facility to see the machines in person, to get kind of feel for how they work, what if they were to buy one, what their day-to-day interaction with it would be. So that was kind of the genesis for coming up with this live stream event. So we wanted to make this as interactive for you to see what you need to see to answer some of the questions you have. So if you have any questions that pop up or any questions right off the bat, throw them in the chat. We have our sales and engineer folks who are on the chat. They'll be able to push some questions to me, so we'll be able to answer them live, show you something about the printer in greater detail that you want to see, need to see. So definitely don't be afraid to throw those out to us. We titled this 5 things you should know about HP printing. One, obviously we're going to cover the HP printing process. The printers have been out for 4 years now. All their printers utilize the same printing process in general. But we'll briefly go over that with the printers we have here in the lab today. Also, we want to look at color parts and why they're making a big impact today for our customers in particular, but all the users of HP. And we want to look at the supply chain solutions that HP printers can help solve. Obviously, over the last year, there's been supply chain strain that's happened for various products, various components. So we wanted to cover that as well. We also wanted to look at the product lifecycle flexibility that you can achieve with just one printer, taking a product from cradle to grave and how HP can be a part of that process at each stage. And then finally, we wanted to look at the mass customization capabilities that are available. That's something that's kind of new and gaining more momentum with HP. So a little bit about Hawkridge Systems. So we are a value-added reseller for the entire SolidWorks suite of software. We offer some CAM solutions as well. The Artec and Hexagon 3D scanners we sell and support as well. And on the additive side in particular, we obviously represent HP, but also Markforged, Post-Process Technologies, AMT, which is a vapor smoothing process for additive parts, and then also the Materialize additive software as well. So with me today is Rob Storleen. I'll let Rob do a brief introduction.
Hi, my name's Rob Storleen. I'm the Application Engineering Manager here at Hawkridge. I'm based with Charlie out of our Minneapolis headquarters here, and we're going to give you a little bit of a tour today.
Yeah, good. So when you all registered, signed up for this, we asked for some questions you had, something you wanted to see ahead of time. So we kind of compiled a list a little bit, and we'll just jump off and talk about those real quick. So one person mentioned wanted to talk more about DFAM. So DFAM is designed for additive manufacturing. It's something we get excited about when people are also excited about it. We've done live events in the past, obviously more than a year ago, where we'd have a full day of talking about DFAM, putting parts in people's laps, talking about how we can redesign this to optimize using additive. But kind of give us your kind of thoughts on DFAM, where it's at, where it's headed.
Yeah, when people talk DFAM, I kind of picture things like how do you design for injection molding? How do you design for casting? How do you design for machining and stuff? With DFAM, it's kind of different. It's not so much about the constraints. Some of it's about minimum wall thicknesses and those things. Yeah. It's more different ways of thinking about the design. So we're not thinking about draft angles and injection points and that kind of stuff like we would with injection molding or vacuum forming. Instead, we're looking at how do we reduce mass, how do we reduce material usage, how do we gain strength by doing that. There's a lot of different tools for it.
Yeah, and part consolidation is another thing. That's a big part of DFAM in general, and it's kind of more about removing traditional constraints.
Correct.
Would kind of be a way to put it, but
This is a great example of it, right? So this is basically an air nozzle. You can see where the fan would hook on the bottom. So this was an original design. They took this and put it through some topology optimization and some flow analysis software. And the software kind of comes up with this crazy little design. We're not constrained by how would we mold this, how would we cast this, how would we machine this, and yet this is optimized specifically for the airflow and the need for this machine. So like I say, it's more about not the constraints, but the different things we can do to open your mind up from the constraints you're used to in normal manufacturing.
Yeah, absolutely. Another question we had, somebody was wondering about the Hawk Ridge Systems service offering. I'll speak to that just in terms of additive. So we help customers investigate whether a certain technology, HP or Markforged, is a good fit for them. And then we sell, we install, and then we service that system for the life of the machine as well. Rob, I have a direct question for you. This is a good one. Can you manufacture consumer products?
Yeah, we do it all the time. The nice thing with HP here is we've got speed, so we can get parts out quickly. We can get quantities out quickly. We've also got materials that make strong parts. So when you see it out there, there's parts on machines and stuff and different pieces of equipment that you don't even know are out there. For instance, like the HP machine here, this 580, has over 100 parts on there that are actually printed on HP systems and used as end-use parts on the machine.
Yeah, and people frankly wouldn't know it's an additive part unless we told you.
Exactly.
Right? Like it looks like an traditional end-use part.
Yep.
Okay. Also, so the most common question that came in was people wanting to know about materials and also different colors. So we're going to jump into that through the course of this. But Rob, let's start on the HP 580. This is the 580 that we have in our Book and Park office. There's also a 540 that just prints white, but let's start with this.
Yeah. So this is the 580. It's a single unit, self-contained. You'll see when we talk about the 5200 here in a little bit, it's multiple units to the machine. This is a single piece. So it's pretty simple on the inside. It's got the table in here where we're going to build our parts. We're going to put powder in here. This is a powder-based system. So our powder will be raked in here, and we're going to be building as this table drops. When we look at the way this whole system works and the way HP's designed is we have powder coming through here. This is a nylon 12 powder, so PA12. It'll bring powder out onto this little table. This carriage will roll across. You can see the roller on the back side. That'll spread that powder, nice even bed of powder on it. Over here's a fusing lamp. So this lamp will light up as we're laying powder down, and it'll put energy into the powder and heat that powder bed just below the melt point of this nylon 12. Once it's got the powder laid down in this warm, which it's happening almost instantaneously, it's very quick, this head will sweep across, and this is carrying the inkjet heads. So these are standard HP inkjet heads. There's a color head in here and a mono head. This will come across and lay down a fusing agent, or some people would call it almost like an ink, but it's a fusing agent. And that's laid out in the cross pattern of that part or that layer. When this sweeps back and parks, this head will come back over again with the fusing lamps on. The fusing lamps will allow that fusing agent to absorb the extra energy off from the lamp. That causes that plastic to go over the top of the melt point and actually fuse that layer to the layer below. So it's almost like fusing sheets of material, even though it's not quite that, right? But we're getting full contact on it. It isn't a point process. It's actually an entire layer fusing to the layer below. This will cycle back over. We'll bring more powder out. We'll do it again and again and again. The build area in here is 13.1 inches by 7.5 inches by 9.8 inches. So we've got a pretty good sized build area here. We can put as many parts in there that'll fit. We can put one big part in there, whatever it takes in there. There's no support. The powder around it is actually the support mechanism for the part. So when we're putting powder up here in the process, if you come around this side, there's two drums in here. This is a fresh material drum, and this is a recycled drum. So when we load this thing with material and we start our printing process, it's going to take 20% of fresh material, and it's going to take 80% of the recycled material. It's going to bring that up and mix it internally in the machine, put it out here for the roller to spread. When we're done with our build, and this is full of powder, it'll go through a cooling cycle, and then the table will vibrate, and it has a vacuum system from the bottom of the table that'll draw that powder back out through the system and put it back into the tanks for the next build. So part of what makes HP economic cost-wise for parts is that we're running an 80% recycled, 20% fresh material. Over on this side, we've got our agent boxes. So if you notice, we have a CMYK, so cyan, magenta, yellow, black, along with a detailing agent, which is a liquid in there that's put down as a coolant around the part, and then our fusing agents. There's a black fusing and a bright white fusing agent. So these are all delivered to the head, just like an inkjet machine that you'd see printing 2D, and it's just laying that down. So the system is pretty simple in most respects. A lot of stuff going on under the hood, but to us and to the operator, it's pretty simple.
Yeah, so we did get a question from Paul Petros beforehand. He wanted to know about the operational requirements. So let's talk about that in relation to the 580.
Yeah, so when we look at it from operation standpoint, it doesn't take a lot of effort by the operator. We can train people pretty easily and pretty quickly to run it. The machine basically plugs into a 220 volt three-phase system and a network connection. We go to each person that we want to feed it, and we'll put software on their computer to be able to position your parts and orient your parts in the build, and then you'll send that through to the printer. It'll pass through a server computer. It's kind of a little piece, but it'll come into here. The operator will then come in, hit the print button on it, start the whole process up. It'll run through its cycle. It'll pull that powder out and be done. A full build on this is around 15 hours or less. So a lot of times the people will start it in the evening. They'll go home. 15 hours is 8 o'clock in the morning. When you come in, your parts are ready to go. From there, you'll brush them off, take off any of the excess powder that you're kind of need to take off there to get them down a little bit. Then you'll take them into a bead blast cabinet. Well, you'll bead blast that with a glass bead media to take the rest of the powder off. From there, it's basically just cleaning up the machine and feeding it the next job and starting it all over again.
Yeah, so it's pretty minimal user interaction. When we look at that 15 hours, it's 15 hours from warm up, print, cool down, part in your hand. So,
Yep.
So let's take a look at some of the parts that we do have. The HP 580 has been out for about 2 years now,
Yep.
and it's obviously gained in popularity. And we have, with Hawk Ridge Systems covering a big chunk of the U.S. and Canada, we have a lot of folks all over the place printing with the 580. Let's talk about who's using it first.
Yeah, so additive is kind of interesting, and who uses additive? If you do prototypes, that's where the industry pretty much started, is everything was prototype. Then we start looking at jigs, fixtures, tooling. If you've got a machine shop, you do any manufacturing, that type of stuff where you need fixtures and holding pieces, it's beautiful for that. And then because of the speed today, color options, the material properties, we're now pushed into that end-use part. That's always been the holy grail to additive, is if we can get to end-use part,
Volume.
we've got it.
Volume is always the
exactly.
Yeah.
And we see people that they'll start by prototyping, and they'll realize, hey, this part is actually functional. Why would we go to a different type of tooling to make these parts when we can take that prototype and actually put it right into production and move it on right through the system?
Yeah, or a bridge to tooling.
A bridge to tooling.
To work their way up to that tooling, really solidify that design before you sink that cost into that tool.
Exactly.
It's a good point. This was a live question. I think this is a good one that we could highlight right away here. How could you tell the difference between a part made from each technology? And this is we could talk quite a bit about this. I would say when we look at this, layer lines is one way you can tell, right?
Right.
You and I have been around every printing process there is and have seen a ton of different materials. So you could look at a part and see the color and know,
Right.
Okay, that was made with SLA or SLS or some other thing. Yeah.
Yep. And like an FDM, you're going to see more layer lines in it. We find with the HP systems, we print with an 80 micron layer. And because I can put it in at any angle that I want, I don't have to worry about support and how it's going to set. I can hide those layer lines pretty well on things. I don't see the bullseye effect. And because of the way this heats powder and stuff, I don't see it. An SLS system being a point process, sometimes you'll be able to pick some of that up. You might be able to pick it up in layer adhesion and strengthen the Z-axis.
Yeah. Which prior to HP really has been the big thing about the Z
Z-strength.
The Z-strength, and that's where you get some issues as far as strength goes.
Right.
Yeah.
Right. Yeah.
So it's kind of hard to tell. Some people can see it just from looking at a part. It would be the main thing. But
you want me to trick you a little bit on this somewhat is at 80 microns, a lot of these geometries, it's basically that roughness of the outside surface. If we put these parts through, say, a vibratory finishing process like post-process or AMT's vapor smoothing system, there's a lot of times where you'd look at something and you're going to be a little challenged by, is this injection molded or not? I mean, it really gets that way. We've got one part, this little guy here, when I vapor smooth this, I actually wanted to go in and put parting lines on it and injection spots because people looked at that. It looked like it was injection molded, but they couldn't find the parting line.
Good. All right, so let's take a look at some of these parts. So with the 580 and the 540, they print with nylon PA12.
Right.
So all of these would be nylon PA12 from the 580.
From the 580. And the reason why is PA12 has been used a lot in SLS and in this for years and years. It's a great material. If you look at this, this is plastic. It's got flexibility. It's got strength. Here, because of color, we've been able to give it some really cool color, options on it. But it's got strength. It's got a good heat deflection on it. Chemical resistance is really good on it. It's just a good overall material. When we start looking at uses, you're saying who uses this?
Yeah.
We see a lot of stuff with color. A few years back, I had a sales guy tell a group of people looking to buy a machine that they don't need color. Well, at the time, it was a sugar cube type thing. It wasn't a functional part. Now we see color being functional. So when you look at stuff like this, if you're a marketing group and you're doing focus groups, look at how fine the little bristles are on this. We're able to print that kind of stuff on it. This might be in a focus group where they print a bunch of these with different shapes, different textures on the outside, different colors. They pass them around the table and say, does this fit good in my hand? Is it too big for my purse? Whatever, right? So focus group stuff. We see this with movie props because you can't tell the difference, especially on camera.
Yep.
We see jigs and fixtures. If you've got a tooling operation, you're machining parts or you're assembling parts. When you start looking at using color for QR codes to identify the part, putting a part number on it, putting directions on it. When you look at the red tag spots on here, those are touch points for the part. The green would be where you'd attach your part. You can put these color codes on there. So if you're doing 5S poke yoke, you're trying to reduce the number of errors by putting directions directly on the part, on the fixture, reducing that. We'd even do it with end use. You look at this, here's a fitting, right? It's got airflow direction on it. It's got a purple nozzle and a red nozzle, so I know which side hooks which hose to the nozzle. It's got a QR code on it for part identification. So when I'm assembling the machine, as long as the person can read the colors or the notes on it, they're going to be able to assemble this without making mistakes. And that's huge, in a manufacturing environment, quick and few mistakes. One of the last ones to point out is this is something that's growing and growing. So this is a medical model. We've got a group here in Minnesota, they use their machine specifically just for this. It's pre-surgical planning. So if they've got a defect in a heart like this, by being able to print this, the doctor's able to look at it before he goes into surgery, start doing his planning on it. If it's a tumor to be removed, they can see the exact size of it, shape of it, where it's located by printing that model ahead of time. This allows the doctor to get in and out quicker, patients under anesthesia for a shorter period of time. He can maybe do more procedures in a day. The operating room's turned over more often. It's a huge win for everybody when it comes to a medical condition like that.
Yeah.
It's kind of a strange little application, but it's so valuable to society.
Yeah. So to go back to it, who's using it? Obviously, we touched on a bunch of different industries here. So it really is all across the board with what industries are using this.
Right.
Education's another big one for especially
Education.
this system with the size and the minimal user interaction it needs.
Yep.
But we sell, Hawkridge sells to some of the biggest companies kind of in North America that we on a daily basis are using, touching, seeing. But we're also selling these systems and the entire HP portfolio to businesses. You fly down a highway going 60 miles an hour and you see a sign and their name is XYZ and you never think about them again.
Right.
So it's those suppliers that are also using it, but it's really across the board. So this isn't pinned into this is a prototype machine. It's not pinned into you need to be a Fortune 500 machine.
Right. It used to be in that price point where people thought, I have to be big to leverage this. They'd see the big airline companies, the aerospace guys leveraging this. And they think, well, it's not for me. I can't do that. But we're seeing these smaller companies able to leverage it the same way. And also, they're usually suppliers to some of these bigger companies.
Yeah. So that's a good point. So to kind of bring it full circle a little bit, we started this off asking about how you could tell different technology from HP just by looking at it. But all these parts could have been printed with technology that was available 5 years ago, right?
Correct.
So, but what makes HP's different from what's previously available, or what else is available now out there?
Yeah, well, some of it is speed, right? With the single coat running back and forth, the way that we build with the HP systems, we've got the speed up on it. The nylon 12 material available, it's not a brittle part. You could drop these. You can beat them up on your production floor. Mm-hmm. They're more than robust, but we're able to get speed. I think that's the big thing. And then that 80-20, 80% fresh to 20% recycle, that just lowers that price that much more because of the high recyclability.
Yeah. So we did get a comment in here. Can you please show/describe the color appearance of parts coming off of the HP 540, and then touch on the dyeing process that users have as an option? So we do have some 540 parts.
We've got some 540 parts. So 540 prints in white. So it's basically just missing the CMYK in there. The rest of it's there. So they'd just be a basic white part. This isn't all that bad because if you're doing a single color, let's say yellow, red, whatever, it's a safety color for a cover for something. We can dye these. We use a RIT dye is how I do it. I've got a pretty much homemade little system back here. It works pretty good. If you're doing this on a professional basis, it's stuff you're putting out there. There's dyeing systems on the market that give you a much better consistent dye, but the white takes dye really well.
Yep. Yeah, we can definitely go darker from white.
We can go darker from white.
But that's just off the 540. That's the only color it prints in nylon PA12.
Yep.
So let us know if you have any more questions on the 580. We're gonna we can come back to it, but we're gonna move towards the 5200 here. The 5200 has been out for just under a year now. So this HP came out 4 years ago with the HP 4200. At the time, the big push was we're going to be fast. We're going to print more parts per day, per hour, or whatever, and we're going to be cheaper. So that was the two big drivers for it. And HP came out with the 5200 after kind of listening to customers, seeing what was out there, and made this faster. Made a more redundant system as well. So that's a 5200. The system is comprised of the printer, which is here, and next is build units. We have two of them here in our office. Customers have two at a minimum, sometimes up to 3, 4, 5 of them, just depending on their use. And then a processing station. So this is where the build units behind me are filled with material. Then they go to the printer. It comes back here to cool, excess powder is removed, and you have your part in hand at the end. One question we did have from Owen Schoeninger previous to the live stream starting was how HP printing technology compares to SLS in terms of material versatility and post-processing requirements. So I'll take that one. Material versatility. With the HP 5200, we can print with nylon PA12, PA12 glass beads for higher temp usage, PA11, which gives a little more elasticity. TPU, TPA, and polypropylene. So SLS has pretty similar materials. So that just gives a brief overview of it. As far as post-processing requirements go, as Rob said, the HP systems, they use a 80-20 recyclability rate. So the best SLS does is about 50-50. So when you're looking at your price per part, that's where HP is much more efficient for the customers. After that, they're still going to need to be removed from the system, taken to bead blast, and then you have your end part in hand. So that's the process, post-processing requirements. Rob, why don't we talk a little bit about the 5200? And I do have a question for you here. How would we go about printing multiple materials using the 5200 system?
Yeah, so when we look at the 5200, like Charlie says, there's 6 materials available. We're not able to run multiple materials within the same build. When the build unit's loaded with, say, nylon 12, that entire part's going to be nylon 12. If we load it up with a TPU or a TPA, that part will be built in TPU, TPA. So what we generally find is the printer can handle any of them. So it doesn't really matter what I'm putting into the printer. I'm going to load my build unit up. I'm going to put it in the printer with, say, PA12 in it. As long as we've calibrated it for that material, the machine will recognize that build unit full of PA12. It'll set all of its parameters, and it'll go through its whole process. We'll pull it over, empty it, repack it, reload it. So what we generally find, though, is if somebody wants to run, say, a TPU and a nylon 12 and a nylon 11, what they'll generally do is they'll have separate processing units for those and separate build units. It's possible in some cases to switch them, but you have to clean the systems out because we don't want to cross-contaminate, say, a TPU material left behind into a PA12 build. So that clean-out process can be pretty extensive depending on the material combination. So most people will have a separate processing station for each material and then a build unit that's kind of assigned to that. And then they'll throw it all in the same printer if they need to. Yeah, does that answer it?
Yeah, that does.
Okay. So let's take a look at this real quick. We can kind of compare it to the 580 over there, give you a quick run through. The process is really the same. We're going to bring powder up into a bed. This bed is 15 inches by 11 inches by 15, so it's bigger than the other system over there. The roller in the back will rake that powder over. Powder will come up on the front and back. Roller will level it. We have a set of lamps up here. It's something that's a little bit different. If you notice, those lamps are in zones. There's a whole series up there. And there's a thermal camera right here in the middle. The other machine has a thermal camera also, so that's how it knows temperature. But this one's actually looking at the bed, and each of these zones is able to be adjusted independently. So as the thermal camera is looking around the bed, if it sees a cold corner, a hot spot, whatever, it'll adjust the intensity of these lamps in order to level that temperature on that bed. It'll cause that powder to basically heat just below the point of the melt point of whatever material we're running, whether that's PA12, whether it's 11, TPU. The head here will come across just like on the other machine. This will sweep across. It has print heads inside. Since this is not color, it has a detailing agent and a fusing agent. It'll lay that down in the cross section of the part. There's also lamps on either side of this print head section. So as we're laying down the fusing agent, these outside fusing lamps will be on. The fusing agent will absorb the energy off these lamps, pushing it over that melt point and fusing it to the layer below, just like the 540, 580 over there. What makes it a little different is by being able to control this in zones, we're able to control the temperature of the bed a little bit better. So there's a software package available for the 5200 called Process Control Software. We can build an entire build of parts. There's a certain suite of parts that we build. We take those and measure them, scan them, get all of our measurements of multiple points on each of those parts. That data is put back into the machine to calibrate the machine to look for a corner or an area where the part might be a little large or a little small so that it can compensate for that. It'll do that through these lamps up on the top. Because of that software, we're able to get to a CPK of 1.33. So if you're not familiar with CPK, we can walk you through it if you want to contact us afterwards. For those of you out there, basically at 1.33 is incredible. There's very few parts that would be thrown away out of that build once this would be calibrated. So we get that accuracy out of it with that software. It's already at a CPK of 1.00 without that software, so we're already accurate and repeatable. But a lot of times when I talk to people, they have this thing about how repeatable is it? How accurate is it? They kind of separate the two. And if you think about it, if you're accurate, it's great. If you're repeatable, it's great. If you're accurate and you're repeatable, then you're right on that dead end bullseye, throwing darts every single time. So the process control software available for this 5200 allows you to get into that really tight CPK and really get accuracy and repeatability locked down. So the process is very similar. One thing that's a little different is here we have these build units that Charlie talked about. So when this build is done, this build unit would slide out with my build in it. I'd roll this over to the processing station, see if our guys here can follow us. So we'd open this up and we'd install the build unit into here. So with this is where we'd cool this build. With any powdered system, when we have this cake, we have to cool that. On a standard SLS system, a lot of times it's a 3-to-1 ratio. So if I do a 10-hour build, I'd be looking at maybe 30 hours of cooling. If I didn't have this build unit able to come out of there, my machine would be tied up for 2 days waiting for the next build. So here I'm able to move it in and cool it in a different spot. 5200 also has a natural cooling unit available that I can take this cake and transfer it into this box, put that on a shelf if I wanted to set it aside for 3 days. The other advantage HP does is they have developed a fast cooling method. So it's a 1-to-1 ratio. So if I do a 10-hour build on the printer, I move it in here and put it into fast cooling, it's a 10-hour cooling cycle on here. So that makes it really efficient because I can turn jobs a lot faster that way. So when I put it in here, I'm going to recover all my powder around my part, pull my parts out. I'll brush the powder off them, take them off for bead blasting to get the last of the powder out of them. To clean up this build unit, this little hose over here is a vacuum hose. I'll pull the rest of my loose powder back in. It'll go into the system. Over on the side here, I have a tank for recycled powder. So this material I'm pulling out will go back in as recycled. When I go to load this again, I'm going to take 80% out of this recycled tank. I'm going to take 20% from a fresh supply. It's going to go into a mixer up above and be dropped through this hose back into the build unit to refill this build unit ready to go. So once I've filled this, I can move it back over to the printer and run a job on it. Because of these build units being interchangeable, I can have one cooling, unpacking, doing whatever I want over here while the printer's running. As soon as that job's done, I can pull it out, stick another one in, clean the printer up, and I turn it over and start printing right away again. So it allows for this continuing production rather than tying the machine up for long periods of time.
Yeah. Rob, we got a good question that just came in. They say, I know other SLS technologies require breathers when handling powders. What type of safety requirements are there for the HP?
This has got a safety shield on it. It also has a laminar airflow in the back, so it's going to draw this powder back through a filter system. So we get a little bit of dust out here, but it's not like I'm having to wear a respirator and all the rest of it when I'm working on this. A few years ago, I was in a place with a full-on SLS, and this was years ago, but I felt sorry for the guys working in there because they were literally sliding their feet, skating because of the powder on the floor. They had full bunny suits on and full respirators. And I looked through the window into this sealed room thinking, wow, what a job. That's just crazy. Yeah. So we've come a long way. So this pretty much contains most of that powder. It isn't an issue really around here.
And when you work with it, your attire is?
About what I wear now.
Exactly. Okay.
Yep.
Okay.
Yeah, I'm not bunny suited up.
Right. Okay, good. Okay, so there was another question that came in. I noticed the 5200 is a different color than the 4200. Was that the only change made to the system? Any upgrades? That's not the only change. They did make it 30% faster, made it more redundant.
Yep. It has a single pass on it, so it's faster.
Yep.
They've added more lamps to the top to give them better control of that bed temperature. The thermal camera on it is twice the resolution, so it can pick up smaller increments in temperatures on the bed. There's a bunch of little improvements like that on it. Well, little, I guess, that's maybe the wrong word.
Yeah.
But looks-wise, you wouldn't see it.
Right.
But there's performance things that have been improved on it.
Yeah, a lot of performance enhancements. Yeah. And HP did that to basically, when they wanted to listen to their customers, listen to the market, see what's out there. And Rob mentioned the CPK. That's a very important thing, because what this can now target is different projects than really what they could do in the past with having that increased accuracy and repeatability. So it's pretty interesting. So now that we're back here at the parts, let's start with the nylon PA12. It was available when they first launched the 4200 4 years ago. It's the most widely used. We sell the most of it. Part of that is due to application. It has a wide application base. But let's talk about the PA12 material to start.
Yeah, when you talk applications, right, machine is part of your application you're doing, but it's mostly material driven. So I'm not going to do a solid part out of a elastomer type material, if that's my application. So the PA12, like we talked about, that the 580 runs PA12. It's strong. It's got great chemical resistance. It's got great heat deflection. It's a really good all-around material. This part's kind of funny. It's 1 inch by 4 inch by 4 inches. It's been topology optimized, and I think this has got a little more than 80% removed from it. So here again, when we talked about DFAM, stuff like this, right? It's like, okay, I could cut this out of a big chunk of metal. I can make this out of a big chunk of plastic, but I can do these types of things in design. Now, you'd look at this and say it's plastic. How strong could that be? We took it outside when I printed this, and we drove my truck up on it. And then everybody made fun of me that my truck isn't a real truck, so we got a Ford Raptor out. We parked that on top of this. It's actually got scratch marks in it from the parking lot where we parked on it. We parked it out there for about an hour on top of it and drove off it. So something like this, designed for additive, it's more about what can I reduce for cost, weight, everything else than constraints.
Yeah.
What's interesting is the same material, a nylon 12 material, right? This is the same stuff, but it's flexible. So by changing the design and the structure, I can get flexibility out of that same nylon material. So same thing with the super strong part. I can make something flexible that's going to absorb energy, reduce weight, do whatever. So that's why it's a really nice material that it'll fit across the whole realm of things.
Yeah, and I think both of those parts are good examples of, right, what additive couldn't do years ago.
Right.
One, parking a truck on it. A plastic part that's 3D printed additive. That's tough to do.
Right.
But did it. But also then having plastic that's able to bend, retain its shape, it rebounds nicely. That's stuff that really wasn't available until HP came.
Right.
So that's the PA12. There's also PA12 glass beads, PA11, as we mentioned. In the last 12 months, HP has released 3 new materials, TPU, TPA, and polypropylene. So let's take a look at those a little bit.
Yeah, so when we get into the TPU, TPAs, they're elastomers. So when we look at parts like this, right, it's squishy. It's more of a rubber type of material, right? It's an elastomer, it's TPU. But if I change the structure on it, again, DFAM, I can make this stiffer and absorb more energy out of it. So I can change the density by changing the design of the interior flow. A lot of times you might see this even covered. This would be the internal structure inside of it. We're seeing this used for things like headrests on cars because it can absorb impact. We have been seeing some stories now. I believe the NHL has now moved to hockey helmets that they'll scan a player's head. They'll print it out of things like this, basically conform straight to his head, custom to him, and they can change the density in areas to give them more impact resistance in some areas, more comfort, those types of things. We've even got stuff like this, if you can get in here, that crazy infill patterns that are designed that'll give us a whole different response than the other one. So this stuff hasn't really been available before because you couldn't mold that, right. At least not easily. So now we're starting to develop almost like new materials, metamaterials, based on, say, a PA 12, a TPU, TPA, but by doing different structures, we can almost create different properties.
Yeah. So that the headrest and the hockey helmet, sporting helmets, is a good example of those people using it in all the different stages of the product life cycle, right?
Right.
They probably prototype using the HP printing process, and then they probably started off as bridge tooling. Do we need to go invest in tooling for it, or can we stick with HP? And then once they get to it, kind of end of life parts
Right.
to service.
Right. We see stuff like that if it's something you can't get back anymore, right? It's an old part. If I need to make one, let's pick something. We had a customer with like switch covers, old control panels. They just needed the little cover over the switch, but they'd have to have a mold made, and then they had to buy thousands of them in order to get the cost down to anything reasonable.
Yeah.
We printed a half a dozen of them to get them going.
Yeah.
And then it's like, well, I've also got these switch covers and I've got this part. It's all old equipment that they can't get parts for.
Mm-hmm.
And they might be hanging on to huge amounts of inventory. Well, once that inventory goes down, what do? You don't want to buy a large volume back again. So we can bridge to tooling. So we're starting with designing a part for low volume manufacture. We don't know how many of these machines we're going to sell. So we want to make just a few. Once it takes off, we might go to mold. Mm-hmm. Oh, wait, now we're at the end of life. This thing's going to die. We don't want to stock inventory. We can print those things just to keep machines going longer out there. Mm-hmm. So not only bridge to life or bridge to tooling, but we've got bridge to death happening out there too.
Right. Yeah, and also speaks to supply chain solutions, right? Like you're controlling your supply chain at that point. You're not relying on somebody else, somebody overseas, where procurement might be difficult. You're your own supply chain for stuff like that.
Right, and we see digital inventory.
Yeah.
It really came out with COVID where we needed to get face shields to locations. Mm-hmm. If they were all injection molded in a plant, let's say in Pittsburgh, but had to be shipped to the West Coast, you've got a day of shipping even overnight. With digital inventory, we can send the file to the West Coast, have them printed right there. We save that shipping. Same with overseas. We're seeing many companies now doing digital inventory overseas where they have a printer in each facility. They may have their design center here, but they'll send the fixturing and the tooling or the parts digitally to the other country and then just have it printed on site as they need it.
Yeah. Okay, so before we get to polypropylene, let's talk about the different colors that are represented here, because coming out of the 4200 or the 5200, the parts come out as one specific color, but there's many represented here.
Yeah, you caught me. No,
I did.
So here's a good example of a raw part coming out of the 5200. So when you look at it, it's got this kind of grayish white look. If we cut it in half, it's black inside. It's just the amount of powder on the outside kind of gives it that little grayish look to it. So if we look around inside the HP machine, a lot of parts look like this because they're internal. They don't need to make them look pretty. They're functional parts. Now, this part that we were saying we drove on, this has been dyed. So like we were talking with the white parts, this was done in my little cheap homemade dye bath back here with a black RIT dye. The other option that we do on them, this is kind of has a little bit of a look to it. These have been graphite blasted. So if you notice they're gray, they're not quite as black. So this is the bead blast media that we use, the glass bead. We mix a little bit of graphite powder into it, and then when we blast it, we'll actually be able to even out that color just by giving it a little bit of a gray graphite look to it. So there's many things we can do. One, two, we can kind of look at, this is maybe a good example. So this is TPU, it's an elastomer. The part was actually dyed black and then vapor smoothed. So we can see a little bit of the layering in it, but that vapor smoothing gives it that shiny appearance and smooths that surface out a little bit. We're getting it closer and closer to an injection molded type of look.
Yeah, that's great. All right, so let's take a look at the polypropylene parts then.
Yeah, so the part you're holding there is polypropylene. It's used quite a bit in automotive. It has some great properties. Things like if you submerge that in water, it doesn't absorb and change dimensions because of material soaking into it. We can weld it very easily. So if you put that cover on and didn't want to attach it with bolts, that could be welded ultrasonically with a heat gun. We can even weld that to other poly-pro parts. So if you're having some parts injection molded, we can print parts that would also be welded straight to that injection molded part. Airtight, watertight, it's an incredible material.
Yeah.
High recyclability too. When we run that in there, we're even higher than an 80-20. We're recycling more material, so the cost is even better on it.
Yeah, yeah. Okay, so Michael Jensen had a question. Where is it heading? What's on the horizon? Let's talk about that briefly.
We're going to get the crystal ball out now and take a look at that.
Yeah.
It's funny because if you look back a few years ago, you wouldn't be able to see some of this coming either.
Right.
You know, I've had an opportunity to talk quite a bit to some of the original guys that started the industry years ago. And I was sitting with one of them one day and I said, did you ever think that what you were starting with prototypes and stuff would actually be in medical facilities doing surgical planning and changing lives? He says, no, we were trying to sell machines.
Yeah.
We were trying to start a business. And look at today where it's gone, right? The efficiency, the supply chain problems. We saw it with COVID and everything, how this helped.
Yeah.
So we're seeing those things. I think the one thing that I see biggest in the future that's making the biggest impact is we have a couple parts here, is mass customization. So we're seeing shoe soles being able to be printed out of materials now. We're able to map your foot, stand on a pressure pad, tells you where your pressure points are. We can change the density of the sole of the shoe or of these orthotics to make them more supportive in places you need support, more cushion where you need the cushion.
Yep.
It's like changing the world. And now because we've got speed and strength, we're able to start pushing that out into a production role rather than that $1 million shoe that's special to you.
Yeah.
It's becoming more and more the realization it's going to be production.
Yeah. Production while customized.
And you're seeing shoes out there now. You can buy 3D printed shoes out there.
Yeah, you can.
It's kind of crazy.
Yep.
This one's the one that excites me the most, I think. Never having braces in my life, but knowing what my son went through. Clear aligners. So this is a little model of a tooth pattern. When you think of the clear aligners today, they scan your teeth, they go in and in software modify the tooth position through the whole series till they get your teeth straight. They print all of these models and they vacuum form those clear aligners over it. So when you walk into one of these plants today, there's hundreds of machines lined up. They're building thousands and thousands and thousands of parts. Not one of them is the same as the other.
Right.
They're all custom with slight variations.
Yep.
And then they're able to track those by patient and get them back to that spot.
Yep.
This industry would have never been practical if
Without
it wouldn't be
additive.
for additive
Yep.
and a strong part and an accurate part.
Yep. Yeah, so the customization is huge. They've been doing aligners with additive for quite a few years. Now companies are gradually moving over to HP to use this, one for the speed and the economics
cost.
of it all, that they're taking advantage of that. But it's cool because every part is truly unique.
I couldn't imagine tracking that.
All right.
I could not imagine tracking that many custom parts.
Right. I had another question. Thomas Yukasin asked, he wanted to see what the current state of the art is. I think we've done a good job showing you that. He said, we don't currently have a vision on how to incorporate technology, but I don't know what the future requirements may be. Future requirements may be for your company. Yeah, that's going to be tough to gather. But we look at kind of the array of parts we put here. This fits a lot of different needs, right? So if requirements do change, there's still use on the manufacturing floor. There's still use for prototypes. There's still parts, if supply chain issues arise, let's just print it. We have the printer here, right? But let's kind of talk about, because he asked, we don't currently have a vision on how to incorporate technology. This is something we
address it all the time.
Yeah, we work with customers. Now it's virtually a lot, but it used to be a lot in person where we'd work with them, meet them at their facility, possibly talking about a specific application, right? Because everybody comes in with
the silver bullet.
The silver bullet. I have this biggest pain problem in my life, and can you solve it? And a lot of times, yes, we could solve it. But we also know just one part a lot of times can't sell an entire machine. So these people come to us wanting a machine, so we kind of help them. So let's kind of talk about that a little bit, because we
Yeah.
we used to do a lot of the in-person at your facility, but how to identify some of these parts.
And when we go on site, it's fairly easy, right? If we do a tour, we can kind of look around and see things. What I always tell everybody to do is kind of try to identify a part that takes a long lead time. Could be a fixture, could be an end-use part, could be a prototype. If it's taking a long time to get that back, if it's costing you a lot of money for that single part or just a couple of those parts, those are good opportunities. We see it all the time where we talked about earlier, people think they have to be a big company to have enough stuff to do.
Yeah.
We'll see stuff go in, person will buy a machine for one particular thing, like we're going to do prototypes. Pretty soon the machine shop hears about it. They have them make a fixture or two. Pretty soon they're consuming so much of the production time with fixturing that they never thought of, that this thing just kind of continues to grow in there. And then their prototype, they found out, oh, we can use that as a functional part right on the machine. Now it becomes a production thing. So the main thing I tell everybody is don't constrain yourself to thinking, I got this one thing, if I could fix this, maybe I could justify a machine, because you're going to find other things. Great example was, stuff this kind of brings to mind a lot of times with these custom grips. I was asked to go into a place a few years ago. They had a machine, it was running at 85% capacity or something like that.
A printer.
A printer.
Yeah.
And they were showing me all the great things they were doing, but they needed a little more use out of it in order to convince the boss to let them buy a second one. So we walked their floor. They were doing incredible things. But all of a sudden, everybody stopped on the production floor. It was like 100,000 square feet of manufacturing floor. Everybody stopped, they start stretching. I'm like, what's going on? He says, we have a lot of repetitive motion injuries. Our medical costs are going up with the company because these guys are doing the same motion every day. They're getting wrist injuries and everything else. So I asked him to show me a little bit. And it was funny because they've got these pneumatic tools hanging from the ceiling. I said, what about the women's hands are smaller than the men's a lot of time. The angle on the handle, if you could change that out during the day, would that maybe reduce some of the fatigue? And I turned around, and of the 4 engineers with me, 2 of them had disappeared. And one guy said, I think you found us an application we hadn't thought about. Mm-hmm. It's this weird thing where they were doing incredible things, and yet there was still another opportunity in there to reduce a medical cost, who would think?
Yeah, those touch points, right? Because there's a lot of different hand sizes out there. Those touch points is part of that customization, right?
Weight reduction on the tool.
Easy to be done with additive. Anything you can touch that multiple people are working on. You have your own set that kind of probably would improve employee morale. They have their own set. They disinfect it, sanitize it before they start work, end work, whatever.
Yep.
Yeah.
I've been told joysticks in some of the fighters are custom to the pilot now.
Yeah.
It's like, why not? His hand's a different size than somebody else. Why not customize some of that stuff?
Yeah. If I was a fighter pilot, I'd like that. I mean, I've wanted to all my life, but we'll see what happens. We'll see what happens. I'm too old now, I guess.
If you only dream when you're sleeping, there's no way for it to come true.
That's right.
Remember that.
Okay, so we did get a good question in here. How much human involvement is there in the 3DP process? Do you have to babysit the system like a CNC machine? So this is a huge question, but let's answer it briefly.
For the most part, additive, the wonderful thing about it is it's hands off, it's lights out. So I was running a lab a few years ago. We had 40 machines in there. I'd tease my guys to put a little extra grease on the lead screws before Christmas time, because we'd leave for 3 days and let the thing run. Not that you're not going to have a problem here and there, but I don't have to have a machine operator watching 2 mills and changing things. Mm-hmm. Once I start the machine, I walk away. So if it's a 15-hour build, if it's a 2-hour build, my time in contact with the machine is pretty minimal. It's cleaning it up afterwards, maybe loading more material in, hitting the button and leaving it. So most of the benchmarks I run in here, I run at night, weekends. I'll start up on Friday and come in on Monday and have my part.
Right. Yeah, and we did talk about kind of the user interaction with the 580. With the 5200, even though it's a much bigger system, it's basically the same. You have a little more square footage to vacuum up between the printer and the processing station, but it's still pretty minimal. We kind of talk about that. It's a little human interaction. If you were to scale up and add multiple printers, multiple processing stations, that's where you start looking at, we need a dedicated operator
Right.
for this system.
Right. I had 40 systems in that lab I was managing with 4 operators doing finishing, maintenance, cleaning, starting jobs. So, I mean, it's not unusual to see that. And we'd see people from machine shops walk in and just be amazed at the few number of people it took to run that much equipment.
Yeah.
So.
Okay, I have another one. I'm going to let you take a stab at this one. Does the system walk you through each step? Looks complicated? Question mark.
Yeah, basically, I guess which step of it? Processing jobs on the front end, it's basically figuring out orientation. When someone buys a system, part of that installation is our application guys training you on orientation. Why would you orient this way? Whatever, how would you pack? Once you've got that down, it's basically like sending it to your printer on your desk. It'll come into the machine. You'll look on the queue, job will be there, you'll hit start. Everything will start to heat up, do its thing. It's not a big thing. When we clean it up, it's very simple too. It's basically vacuuming up any powder on the inside. When we look at the 5200, it's cleaning off the thermal camera, cleaning the glass on the lamps.
Yep.
It's no more maintenance than that.
Yeah.
There's some stuff long-term that you're changing filters out. You're maybe pulling some areas off and cleaning powder out of some hard-to-get-at areas. But it's not hard. It's a very simple list.
Yeah, and we cover those regularly scheduled maintenance items. We teach you how to do it, when to do it during the install period. And those are pretty minimal as far as your user interaction with it.
Correct.
The system, HP did do a good job of, it does somewhat walk you through it. It will show you what to open, where to open it on the screens. The touch points are all clearly marked here.
Yep.
A high schooler could run this system.
Yeah. HP did a really good job too, because there's things on here where there's little blue markers.
Yeah.
Those are where customers touch. The 580 even more so. It was built more around the idea of their printers and copier machines, where pieces in there are more modular. So you're removing, let's say on a 5200, the cleaning roll in, there's a roll. You have to spool it up around and hook it on the take-up side. Here it's a module that just claps in, claps out. The lamp on a 580 is just 4 bolts. Take the lamp off, bolt new one on. It's really simple. And the screen does walk you through clean this, almost to the point where I've done this enough times. Why are you telling me all these little steps? But it is there. So a new operator is easy to train because it's step by step on the screen on that 580.
Yeah, so that walks us right into another question that came in. Can I use an intern to operate the system, or will I need to hire a full-time operator, in your opinion? Yeah, it would be our opinion. We kind of went over it. You don't necessarily need to have a full-time operator unless you are scaling up with multiple machines.
Right. We see places where the engineers would feed it themselves, but the engineers are busy engineering and designing, so they may not have the time to do it. So you might hire someone like an intern or just about anybody to run it. I always tease that if I can run it, almost anybody can run it. Because I look at a machinist, there's no way I can do that job. That's a high-skilled job. But I actually have taught a 10-year-old how to start the machine up. So it can be that simple.
Yeah, it really can. And that's something we can always talk about, right? Like ask us these questions. How much time, kind of if I'm printing 3 times a week, 8 times a week, like what does this look like? That's always questions you can come to us, the Hawk Ridge sales team with, and we'll bring in the engineers as well to kind of talk through it. So I'm not seeing any more questions on our end, but and we're almost up to an hour right now. So we want to thank you for joining us today. In the chat, our sales and engineer team will stay there for a while. So if you do have additional questions, put them in there. They'll be able to answer them here as long as you stay on. But we really appreciate you guys joining us today. We'll be doing another event here shortly. So keep an eye on the email and the Hawk Ridge website for more information. Thank you.
All right. Thanks.